Hello, this is Brother Krumar from the Math Department of BYU, Idaho, and this is what I'm covering is Lesson 19, which is dealing with inference for two-proportion. So here's the outline for Lesson 19. First, I'll review primarily from Lesson 18, which is one proportion. Then I'll cover confidence intervals, and then I'll wrap it up with hypothesis testing. So first, let's review again the difference between a parameter and a statistic. So a parameter is a measure of the population that's typically unknown, but we like to estimate. So back in Unit 2, it was the population mean, or mu, and now it's p, which is our population proportion. Then a statistic is a measure from a sample, and the statistic is used to measure the unknown parameter. So x bar, which is our sample mean, that was back in Unit 2, and now it's p hat, which is our sample proportion. So x bar estimates mu, and then p hat estimates p. Now there's many different types of symbols that we've used dealing with p for this unit, okay, and here's a list of them. So for instance, p hat is our sample proportion, p is our population proportion, and then p naught, and p naught is not in the online textbook, but it is in this video and in the last video, so I'm just including it here. P naught is the population proportion for the null hypothesis. You can also use p as well, but just so that you're clear on that for this video, that p naught represents null hypothesis, and p tilde is the adjusted sample proportion, where now we're dealing, so back with one proportion it was x1 plus 2 divided by n1 plus 4. Okay, and speaking of that p tilde, we have a confidence interval where we dealt with the plus 4 confidence interval, where p tilde is equal to x plus 2 divided by n plus 4. Z is a critical value from the z distribution, and then n is our sample size, and everything to the right of the plus or minus sign is the margin of error. And where we had you do calculations if you want to, though you can do this by hand, is just using this Excel tool, which is a really very nice tool to use to getting our confidence interval. Okay, and then let's see, going with then we also did hypothesis testing for one proportion. So, and these steps are very similar to other steps that we've covered dealing with hypothesis testing, where we state the null and alternative hypothesis. You have the test statistics. So notice here there's p hat, which is our sample proportion, minus p naught, which is our proportion for the null hypothesis, and then we divide it by the standard deviation, where we take the null hypothesis times 1 minus that divided by n and square root that. Then from there we get the p-value, and we can use the applet, or we could use the Excel tool in here to get our test statistic, as well as get our p-value as well too. We can get our p-value from Excel, or you can use the applet for this. But then the last two steps are the same two steps that you've seen before. If you reject the null, then we reject the null, excuse me, if our p-value is less than the level of significance, and then if not, then we don't reject, and then we state our conclusions based on what we did on the previous step, and we state the conclusions using the alternative hypothesis. In the second to last step, we state based off the null hypothesis, or using the null hypothesis. So now what I'd like to do is cover a confidence interval. Okay, so a confidence interval, here's the formula for the confidence interval. Now I have two p tildes here. I have p tilde 1 and p tilde 2. Now notice the formulas here, they look very similar to what we did with one proportion, but they're a little bit different. So if you look at the one, let's go back to the one proportion. This is where p tilde is x plus 2 divided by n plus 4. Now it's similar, but now what we're doing is that we're only adding 1 to the numerator and adding 2 to the denominator for each of the p tildes. Okay, and this is similar to the plus 4 estimator that we did with one proportion. Z is a critical value from a z distribution like we've seen before. We have two sample sizes, one for each group, and then everything to the right of the plus or minus sign is the margin of error. Okay, so let's go through an example that's also in the textbook. So the Royal Botanic Gardens, Cranbourne, is a 914-acre conservation reserve outside of Melbourne, Australia. Predation by foxes have been an ongoing problem in the gardens. To reduce the risk to native species, a systematic program of killing foxes was implemented. One way to monitor the presence of foxes is to look for fox tracks in specific sandy areas called sandpads. Before beginning a systematic effort to reduce the fox population, ecologists observed fox tracks in the sandpads 566 out of 950 times the sandpads were observed. After eliminating some of the foxes, the ecologists observed fox tracks in the sandpads 268 times out of the 1359 times they checked the sandpads. The ecologist wants to know if there is a difference in the in the proportion of times the fox tracks are observed before versus after the intervention to reduce the fox population. So what we can do to check to see if there is a difference, we can create a confidence interval. And it would be a confidence interval of the difference between the two proportions. It's similar to, say, back in Unit 2 where we dealt with the difference between two independent sample means. We compare those means. Here we're comparing two proportions. Okay, so what we'll do is that we're going to take this information and put this into our Excel. You can do this by hand, though it's more unwieldy if you do it by hand. So I'm going to take 576, that's x1, and then it's n1, which is 950. Okay, and then x2 is 268, and then n2 is 1359. Okay, and so when we calculate it down below here, this is our confidence interval. Okay, and so we are 95% confident that the true proportion difference, or the difference between the proportions, and it's right down here, 95% confident it's between 0.3709 and 0.4406. One thing to mention here, you can change the level of confidence. I didn't mention that earlier, but you can change it here in decimal form. But I kept it at 95%. And so in this case, just like with independent samples as well as matched pairs, since 0 is not in the confidence interval, then there is a difference in the proportion of times fox tracks are observed before versus after the intervention to reduce the fox population. Okay, and so then, doing some things before doing a confidence interval, there's requirements and descriptive statistics to do or to check. Requirements, both sample sizes have to be greater than or equal to 5. Okay, now in this example here, they're both well beyond 5, and so those requirements are met. And so for the descriptive statistics, we can list the sample proportions, and the graphs is the pie charts or the bar graphs. Now the sample proportions you can get from Excel. Here's our two sample proportions. Okay, but the pie charts and the bar graphs I'll cover a little bit. I'll cover in part 2 of the presentation. So I'm going to wrap up part 1, and when we get to part 2, we'll cover hypothesis testing, and then we'll wrap it up.